Okay, once again, good day everyone. Welcome to Marina's Powerhouse Team Review Center. So we are going to continue our lecture about the AC circuits, no? Single phase AC circuit. So our topic for today is about the power in AC circuits. Okay, let's discuss this. We have the complex power formulas. By definition, the complex power formulas is, so we have here our S that is equal to P plus JQ. Well, actually, this JQ, it can be positive, it can be negative. So I will draw first in our board what we call the power triangle. Let's call this as the power triangle. So our power triangle is one of the most important triangle in AC circuits. This is our theta, this is our S, this is our P, this is our Q. Okay. So our S in rectangular form, this is equal to P plus minus JQ. If we are to convert this into polar form, our S simply equal to magnitude of S, okay? Magnitude of S, then cis of plus minus theta. Remember that if we mean positive, okay, we mean it is capacitive. Again, if we mean capacitive, that is leading power factor. That is always leading power factor. If we mean negative, we mean inductive. Inductive. We mean lagging power factor. Okay? That is lagging power factor. Now, take a look here. So the S having component P and Q, where S is the complex power in volt amperes in VA, S is equal to VI, voltage times current, that is the apparent power in volt amperes. P is the real power in watts, Q is the reactive power in volt ampere reactive. No? We mean bar, that is the unit of Q. Remember, the real power is in watts. The reactive power is in bar or bars. This is the volt ampere. We mean volt ampere reactive. No? Okay? Now, we have here our S, magnitude is equal to the magnitude of S, absolute value, cis of plus minus theta. Okay? This plus minus theta. Now, this is also, well, of course, our S simply equal to the voltage times current. Okay? Plus minus theta. Because S, of course, is the product of the voltage times current. That is why the unit of S is in volt ampere. That is volt ampere. That is the product of the voltage and the current. Now, we have here our P. Huh? We have here our P. Our P is equal to S multiplied by cosine theta. No? Our Q is equal to what? S multiplied by sine theta. Okay? Well, of course, we may replace S by volt ampere. No? So, the cosine theta, take note, that is what we call the power factor. PF is the power factor. Take a look here. If this is the power factor, so cosine theta, SOCA TOA. See, we have here SOCA TOA. Okay? So, meaning we have here the sine function is equal to the opposite over hypotenuse. The sine function, okay, what is the opposite? Remember that the Q is the opposite side, no? That is the opposite side. The P is the adjacent side, adjacent side. The S is what we call the hypotenuse. The hypotenuse. Okay? So, katawa, sine function is opposite over hypotenuse. Then, cosine function is adjacent over hypotenuse. We have here the cosine. That is adjacent. Cosine is adjacent over hypotenuse, which is equal to, the adjacent is P. Okay? The adjacent is P. Over the hypotenuse, we have here our S. What about now the sine theta? Sine theta is what we call RF, or what we call the reactive factor. Okay. What is sine theta? Sine theta is opposite over hypotenuse. No? Sine theta, what is the opposite? So we have here Q. Q over S. The hypotenuse is S. That is why if you are to get your Q, that will just become S sine theta. You will see this one. You go back here. If you are to get your P here, cross multiply this S, that is just simply S cosine theta. Okay? And then there are some formula here. Okay? As you see here, so we have here our triangle, power triangle. So you see, the P is always 0 degree real component. And the Q is always the imaginary component. The one with the J is what we call the imaginary component. So we have positive J here. Of course, the hypotenuse is the S. Okay? So, or S is VI. Okay? So that one. Now, so, well, if you have your negative Q, if you have your negative Q, instead of having here upward, you will have negative Q downward. The one we are seeing here now is for capacitive. Capacitive. Pang-capacitive to. What about pang-inductive? Pang-inductive, nasa baba naman siya. Pag ano naman yung triangle natin. Okay? So, ganon. Nakukuha ba, mga ka-aware pa? Gets ba yun? Pag inductive, nasa baba yung triangle mo. Kasi negative Q ang inductive. No? So, baliktad na dito, ha? No? That is the opposite of the impedance. What do I mean? Because in impedance, magnitude of C is plus minus theta. Or apparent power. If we are given the positive angle, if we mean positive angle, meaning, again, we mean capacity. Okay? They have the same sound, right? Positive, capacity. See? Halos magkatunog di ba? Positive, capacitive. So, negative is inductive, of course. Positive is capacitive. But what about in impedance? The positive here is not capacitive. It is inductive. That is opposite, right? You have to distinguish the two. Okay? So, we have here our sample problem. I show you the sample problem. This one. Okay? So, dito muna tayo, partner. Ha? Okay, so we have an AC voltage. No? We have a series RL circuit here. Okay, let us solve this problem. So we have here an AC voltage, no? We have an AC voltage with RMS value of 115 volts. It's applied to a load impedance of R. So we have here 75 ohms. And X sub L, we have 38 ohms. Find the value of the real power, reactive power. We will also calculate the apparent power, the complex apparent power, Then we can show to you the phasor diagram. Okay, the power triangle. Okay. So we have here our, let us get first our impedance. No? So kunin muna natin yung impedance natin. For number, this problem. So we have here our impedance for problem number 1. Next meeting, we'll show you more example. Number 1, sorry. Okay, we can go directly solving our impedance. So our Z is equal to 75. Then we have here plus J, 38. 38 ohms. Okay. Let us get, this is actually our total impedance for this RL series circuit. So what is our total impedance? Let us convert this one. Mode 1. Okay. Then shift plus. So we have here 75. Shift, close parenthesis, so comma. So we have here 38 equals. So our impedance is 84.077 or 0.8. Let's make this a 0.8. No? What is the angle? 26, positive 26.87. Okay. So let us have our current here. By Ohm's law, that is equal to the total voltage over total impedance. We have here our total voltage. Our total voltage is 115 volts. That's given. 115 volts. There's no given angle here, right, for our voltage. So that is automatically 0 degree. Our impedance is 84.08. Bar angle, 26.87 degrees. Take note here that our current will be equal to, we have to divide this first. 115 divided by 84.08 equals S to D, so we have here 1.37. Then what about now the angle? 0 minus. Okay, so you have to subtract the angle, right? If you are dividing the two. 0 minus. So we have here negative 26.87 degrees. Okay? Take a look here. This 26.87, that is your theta. That is the impedance angle. That is also the angle in the power here. The 26.87 degrees. Always remember that. Now, we can now calculate the real power. What is the real power? That is equal to the voltage times the current times the power factor. Or shall we say the cosine theta. What is the voltage? 115. What is the current? 1.37. Then, multiplied by cosine 26.87 degrees. Take a look here. 115 times 1.37 times cosine 26.87. So our answer is 140.54. 140.54. 0.54 watts. Okay. Now, there is the other way of solving our real power. Or, shall we say or? Our power is equal to I squared R. Please take note of this. What is our current? 1.37. Okay, that should be squared. Then multiply by the resistance. This is the resistance, the 75. So therefore, our power here is 1.37 x squared. Then times 75 equals. So the answer would be 140.77 watts. Actually, they are just equal. No? Forget about the very little difference. Okay? Ang nakita mo, yung maliit na diferensya, yung malaki na to, di mo nakita. Right? So, forget about that. They are the same, actually. They are just the same. So, our answer is 140.54. Then, I will solve, okay, our Q. What is our Q? Our Q is equal to voltage times current times sine theta. Okay, let us substitute. What is our voltage? 115 times the current, 1.37 times sine 26.87 degrees. Okay, let's continue this one. 115 times 1.37 times sine function of 26.87 close parentheses. That is equal to 71.21. 21. Okay, bar. Volt ampere reactive. That is our Q. That is our Q. Okay. Now, let us get our S. Remember that our S is equal to P, okay, plus minus. Take note. This is inductive. So if that is inductive, that should be minus JQ. Minus JQ. So we have here, what is our P here? I will make use of 140.54. 140.54. Then minus J, 71.21. Okay, let us convert this into polar form. Okay, mode 1 in your calculator. So you have here shift plus, so we have here 140.54 shift close parentheses. So we have here 71.21. Okay. By the way, it is negative, right? That should be negative. Put a negative sign here. So negative yun, ano? Oh, equals. So our answer, 157.55. So bar angle, negative 26.87. You see, this is the volt ampere. You see, they're just the same. The angle, the magnitude of the angle. In the impedance, 26.87. In the power, this is your theta. No? Theta of the apparent power S. This is the theta of the impedance. You see? Okay? If you have a positive theta in impedance, that is inductive. If you have a negative angle in the power, that is inducting also. Okay? That is also inductive. See? There's another way of getting our S by Pythagorean theorem. S is equal to P squared plus Q squared. You see that is equal to, what is our P? 140.54 squared plus, just get the magnitude here. Forget about the negative here. So 71.21 squared. Kasi puro magnitude lang naman yan. It doesn't affect. Eh, pag in-square mo ay negative kasi positive din. Ganun din, di ba? So we have here the square root of 140.54 x squared, then plus 71.21 x squared. Okay, that is equal to, still the same, 157.55. 157.55. This is volt ampere. Anyway, this is just a magnitude. Magnitude lang to. No? Mas maganda to, meron ng angle. No? This is better. No? It has an angle already. Okay? Okay, mga kawerpa. No? Our answer will be letter D. No? We just had here the real power and the reactive power. No? Okay? So, that's it. No? Then what about the phasor diagram? Okay, I'll show you the phasor diagram. I'll show it here, the phasor diagram. Okay, since it is the negative JQ. Negative JQ. So, let's say this is our P. Our P is always the real component. Real component, this is our P. Okay? Then this is negative J, meaning if that is negative J, that is downward. That is downward here. Downward here. Let's say somewhere here. This is our negative JQ. Let us project the magnitude of this, no? Here. Let's say if this is 3 inches, project the 3 inches here. That one. Okay? If this is 5 inches, you project here the 5 inches. See? That one. Then their intersection here, going to the origin, this will now be your S. And this is our theta, which is the negative 26.87. So therefore, this is our Q. That is on a downward direction because this is a lagging power factor. If it is leading power factor, it should be upward. The Q is upward. Okay? If that is lagging power factor, the Q is downward. So please take note of these basic principles. Huh? Okay, mga kawerpa. So, well, that's it for this topic, the series AC circuit. No? But before we end, let me share to you this energizer of the day, mga kawerpa. Okay, nakakuha po ba yung ating lesson for today? Nakasunod po ba? Okay, so let's have the energizer of the day. So, ito'y galing sa Colossus 4:5. Magsilakad kayo na may karunungan na nga sa labas, na inyong samantalahin ang panahon. In Colossians 4:5, walk in wisdom towards the outsider, making the best use of the time. No? So, let us not waste time. No? Huwag tayo magsasayang ng oras. No? Let us walk with wisdom, no? Mga kawerpa. Okay? So, let's go now to our social media reactions. Kay Mark Anthony Encina, salamat Kuya Red sa libreng pagtuturo. Isa po kayo sa gumising sa pangarap namin bilang mag-aaral para mas maintindihan namin yung sa larangan ng electrical. God bless po. Jake Lloyd Paradela, thank you for never failing to give us knowledge in every webinars you gave. Thank you for the staff of MPHT, UNTV, and to never-ending vocation of Kuya Rez for sharing his knowledge to us. Thank you. Oliver Yungka Lumibaw, Kuya Rez, salamat po sa ganitong libre na pagtuturo. Marami po akong natututunan kahit na di ako engineering graduate. Kaya lagi po akong ma-attend pag linggo. Thanks, MPHT. God bless. Melka Liana, salamat po MPHT sa patuloy ninyong pagtulong ng libre. Dahil po sa inyo ay di po nasasayang yung oras namin at nakakapag-review o aral po kami kahit pa unti-unti. More power po MPHT. Thanks be to God. Terps Daroy Magbanwa, thank you so much for this educating the webinars. Thank you so much MPHT for bringing this to us at our homes. Kuya Rex greatly differs from my engineering professors. Kuya Rex does not just explain and demonstrate. He is a great teacher who inspires as he inspires me at age of 51. Keep the torch burning. I am really 100% to support him and the MPHT community. Really hoping that when the pandemic is over, I can repay your great heart. Thanks be to God. Hashtag learn, learn, learn with Kuya Reg and the MPHT. Alan Estrada Tablada, thanks be to God. Huwag po tayo magsasawang manood kasi kung hindi maintindihan ang tinuro sa araw na yon, sigurado ako matututunan mo sa susunod na panonood mo. Kasi ako madaling matuto pero tiyaga lang sa tulong at gabay ng MPHT, UNTV, at Kuya Reg at higit sa lahat sa ating Panginoon. Mark Anthony Heraldo, napakasarap mag-aral kapag may tumutulong sa iyo at malinaw na pagpapaliwanag, lalo na sa PEC. MPHT, Kuya Reg, at UNTV, salamat for sharing, blessing, at yung mga video na ginagawa nyo ay pwede naming ulit-ulitin. Sa mga hindi pa nakasubscribe, subscribe na kayo, like and share, and click the notification bell para updated kayo sa mga bago pang video. Maraming salamat sa Diyos. Nelson Rosanto, a big effort and help for interpreting and sharing with us the concept of PEC that guide us during site electrical installation and operation. Thank you, MPHT, Kuya Reg, and the staff, and the UNTV, MCGI, Brother Eli Soriano, and Kuya Daniel Razon. God bless. Sasi Imperial, thank you po. Worth it po lahat ito dahil may natutunan po kami at libre pa. Appreciate namin yung ginagawa niya po. God bless. Dandan Rivera Baldono, salamat po sa Team MPHT at sa UNTV sa lahat ng ayudang kaalaman na ibinabahagi nyo po sa mga katulad kong gustong matuto sa larangan ng electrical. Salamat po Kuya Reg at sa lahat ng staff nyo. More power po. Okay, yan po ang ating mga social media reaction, mga kawer pa, no? Sana mas maganda, o kahit wag nyo na po akong pasalamatan, mas maganda yung thanks be to God na lang po, no? Sapat na po yun, kumpleto na po sa amin yun. Sabihin nyo lang po sa amin, thanks be to God. MPHT Review Center, mas masarap pakinggan po yun, mga kawer pa.